everyone. Today we're going to do lesson 1.6, which is an introduction to standard deviation. So standard deviation from the mean is the most commonly used measure for spread. Sometimes it's also called the variance. Now remember, we've already talked about mean and median, which are measures of center, mean being the most used measure of center and that being the average, where median is the exact center of your data. What standard deviation is going to do is it's going to measure the spread, like how spread out the data is. And we've got a good illustration here where we're going to look at points scored over the first 10 basketball games for two different teams. So a qualitative description of standard deviation is just the typical distance from the mean. So let's just get into it. Let's look at the example. So I've got two teams, the Purdue Boilermakers and the Indiana Hoosiers. I was born in Indiana, so I grew up watching these two teams play a good bit. So in the first Purdue Boilermakers team, over their first 10 games, we're going to do little dot plots. They scored 69 points. Then they scored 70 points 2 times. Next, they scored 72 points in one game, 73 points in a game, 74 points in a game, no 75 or 76, but they did score 77 points in one of the games. They scored 78 points twice, and they scored 79 points one time. So that was what the Purdue Boilermakers over the first 10 basketball games, not necessarily in that order. Now the Indiana Hoosiers in their first 10 basketball games, they had one game where they scored 69 points, one game where they scored 73. Then they scored exactly 74 points 6 times. 2, 3, 4, 5, 6. 75 points once and 79 points once. So just on first sight, as you're looking at these two data sets, hopefully you're noticing that it looks like the Purdue Boilermakers have data that is more spread out. Looks like a higher variance than the Indiana Hoosiers. If I look at both of them, they both have the same mean of 74. They both have the same range of 10. 79 minus 69, a review of range is the max minus the min, so they both have a range of 10. But their standard deviations are probably going to be a little bit different. So we're going to talk about how to calculate an estimated standard deviation in a few slides. And the Fathom program is really excellent. You can input your data and add basic statistics, and it'll tell you the standard deviation. So that's what I've done in advance. And so when I put this data into the Fathom program, it tells me that for Purdue, the standard deviation, we'll review notation in a little bit, but I'm going to use a little s, is 3.77. While the standard deviation for Indiana, like I expected, is a little lower at 2.4037. I can go out a few more decimal places. And this is 3.77124 if you're interested. So you can see, with this being a higher number, it tells me just that the data is more spread out. Than this data set. So let's talk about how to calculate a standard deviation, just an estimation if I don't have a computer like Fathom or I don't have Excel. Or a TI Inspire calculator, I believe, does this. So consider these quiz scores. The quiz is out of 10 points and looks like there's 12 scores here. So let's say there's 12 students in a class, and here are their scores. So the typical distance from the mean, or standard deviation, can be calculated first by just finding, well, what is the distance from the mean of these data points? So if I line up my data points, I'm just going to do it in order. 9, 8, 9, 8, 7, 6, 9, 10, 8, 9, 9, 10. Extend my table here. And now I just think, well, how far away are these from the mean? First, I got to find the mean. So if I add all of these up divide by 12, I find that the mean is going to be 8.5. So now if I'm just calculating distance from the mean, remember, I don't care if it's positive or negative. I don't really care if it's above or below. I just want to know the distance. So if I take 9 and 8.5, that distance is 0.5. The distance from 8 to 8.5 is 0.5. 9 is 0.5. 8 is 0.5. 7 is going to be 1.5. 6 is going to be 2.5. 9 is 0.5. 10 is going to be 1.5 units away. 8 is 0.5. 9 is 0.5. 9 is 0.5. And 10 is going to be 1.5. So those are all my distances from the mean. So now all I need to do is, if I want to know what the typical distance from the mean is, I'm going to take all of these numbers. So I'm just highlighting all of these in yellow. And I'm going to find the average of all these numbers right here. So find the average. And that's going to give you an estimated standard deviation. So let's go ahead and calculate that. If I take all of these numbers and I add them up and divide by 12, I get a standard deviation of about 0.916667. So the standard deviation is pretty close to 1, so 9.9. Now when I plug this into my Fathom program, the actual standard deviation was equal to 1.16775. So really not too bad. At estimating that standard deviation. So that's how you can estimate it if you don't have a program that can work this for you. And for those who are planning to take AP Statistics, we're going to talk some notation here, and I'm going to show you the formula that you would use to find the actual standard deviation. So populations versus samples. If you can collect data from an entire population, we report that population mean and that population standard deviation. I would say that's usually pretty rare that you can get an entire population. So most often what we can only get is a sample set of data from an entire population. And then we're reporting a sample mean and a sample standard deviation. So this is probably most common. And for those interested in taking AP Stats in the future, or a college level statistics course, you're going to talk a lot about this. So when we can get a sample, we've been doing this, a sample mean, we use the notation, this notation here, this x bar, and we're going to use a little s for this standard deviation. If you're taking this class with me, this function stat and trig course, or a alternate to pre-calculus, this is what we're going to be using a lot. If you can get an entire population, well then we call that mu, and for an entire standard deviation, sigma. And so down here you can see these formulas that are used in AP Statistics that we're not going to really go into, but you can see how here, loosely, you are adding up all of the differences from your data points to your mean, and here taking the average of those. So you can kind of see loosely what we just did in our estimation. All right, so the next part of the lesson is an exploratory part of the lesson. You're going to open the Fathom file called Estimate Mean and Standard Deviation, and in that you've got a box where you can change the mean and the standard deviation, and then you're going to see how it changes a histogram and a box plot. And you're going to fill in the chart below with your observations. So once you hit that play button, it's either going to make it larger or smaller, and I want you to keep hitting play until you make some observations, and pause this video, and then you can come back to it and see if your observations match what mine are. Okay, so hopefully you've had some good time to go through the program and see what's going on with these different displays. So the first section right here, we're mainly looking at the mean of the histogram and the box plot. And you're supposed to say what happens whenever you have a large versus a small mean. So hopefully you saw that whenever you have a small mean, the histogram and the box plot, they both are centered to the left. So the mean, a small mean pushed the center to the left, whereas a large mean took it and it centered the display to the right. And this happened both in the histogram and the box plot. Then when you were looking at standard deviations, now we're looking here, if you had a small standard deviation, the histogram and the box plot both got skinny or narrow. Whereas if you had a large standard deviation, they got very wide and more spread out. So I'm hoping that is what you saw. So the next is a partner exercise, but of course you could do it by yourself. Work with a partner, and you're going to create 3 different data sets in the Fathom program. The first one is a data set where you've got 14 numbers that contains a mean of 8 and a standard deviation of 3. The second one, only 8 numbers with a mean of 85 and a standard deviation of 1.5. And the third one, a data set of 10 numbers that has a mean of 15 with a standard deviation of 9. So my hint here is usually to set the mean first. And I can go through this quickly right here on number 1. So if you have 14 numbers, so 14 data points or data values, and a mean of 8. That means when you take the sum of all these numbers and divide them by 14, you should get 8. So if I was going to solve for that sum, I'd multiply by 14 on both sides. So I know that these numbers have to add to be, let's see, 8 times 10 is 80, plus 8 times 4 is 24. So they have to add up to be 104. So you're looking at 14 numbers that add up to be this 104. So I might set that first and then look and see, well, what is the standard deviation? Am I even close to 3 with the numbers that you pick? And from there I would adjust. So if you get something really large, that means your numbers are too spread out and you're going to need to get them closer together. If it's too small, if it's smaller than 3, well, that means you need to spread them further out. So have fun doing this with 1, 2, and 3. I really think that once you get through these exercises, you're really going to feel comfortable with standard deviation. And after that, you'll be all ready to do the problem set 1.6. I hope you guys enjoyed this.